Hello CEA. This is lesson 3.2.2, loads and load paths. Alright, so we've got a whole pile of different loading conditions and things that could be loaded onto a structure that need to be taken into account when you are designing that structure. So let's go and take a look at each of those, see what they mean and how we're going to apply those. Dead loads are the one type of loading that you can actually calculate and know and not just take an estimate of. So it's the actual weight of those building components, the floor, the roof, the trusses, the columns, all of those kinds of things. You can figure out pretty accurately what the actual weight of those. It also includes the weight of fixed service equipment. So you're seeing this picture down here, but also anything like rooftop air handling units, HVAC, things like that. Those would be parts of the dead load. Then you have live load. Live load is something that you can figure out after you've figured out what the occupancy of the building is, and that will be in the building code. And then once you figure out the occupancy of the building, then you can go to the building code and figure out what the live load is specified for that type of building occupancy. Yeah, so if you have something that has light manufacturing in it, or if you have an office building, obviously you would have to make the whole structure of the manufacturing a little bit more robust than that of an office building. And so that is all going to be part of your live load, and that is depending on how you're going to actually use that, how the building is going to be used. Okay, then we have snow loads. Snow loads are a little bit more complicated, and rightly so, because buildings fall apart if there's too much snow on them and they haven't been built properly. So all kinds of stuff is part of the calculation of the snow loads. So first of all, the snow load itself is the force of accumulated snow on a roof. It's specified in building codes, and it is dependent on a whole pile of things like location, exposure to wind, importance of a building, roof slope. Let's look at what all of those look like. So when you are calculating the snow load, what you're looking for is this magic number PS, or the design snow load. So we have this formula for your design snow load, and it involves all of these things underneath. Let me talk a little bit about what those things underneath all involve. So CS is your roof slope factor. So it makes sense that if you have a roof that is nearly a flat roof, the snow is going to accumulate a little bit more easily on that roof than it would on, let's say, a super steep roof. And so in the building code, it has numbers that reflect the slope of the roof, and will modify your design snow load accordingly. Then you have the exposure factor. If you have a roof that is in wide open areas and is going to have a lot of exposure, as opposed to a roof that is somewhat sheltered, you will accumulate more snow on the more sheltered roof. Thermal factor is based on whether the building is heated, and what type of materials. Basically, how quickly will that snow melt. Then you have this importance factor. If you have a bunch of people that are in the building and the roof starts failing and it's really difficult to get them out, like in a hospital or something like that, then you need to ramp up the design a little bit and make sure that you're super duper crazy sure that this roof is going to hold up. And so the importance factor is just going to add a little bit of weight to, is going to increase your design snow load by a little bit, as opposed to if you had a building that was just going to be like a driving shed or something where you'd keep some tractors in or something like that. That might not have as high of an importance factor. And then probably the most important piece of this all is that ground snow load, and that's based on your location. So your ground snow load, if you are in Florida, is probably not going to be too high as opposed to if you are in somewhere like Alaska where you'll have really high ground snow loads. And so that is all determined by the building code, and that is something that you can find based on your location with some maps. These here are some modifiers, and so what the building code does is it wants to make sure that everything is super duper safe. And so they have these checks and balances. And so when we go to do the actual assignment, we'll go a little bit deeper into here. But what this is saying is that your design snow load needs to be modified based on certain conditions. And you just need to check these things out and make sure that you're within these parameters. Okay, then we have these lateral loads. We have wind loads, earthquake loads, flood loads, earth pressure loads. What you're going to do is in your engineering notebook, you're going to draw something that's a little bit like this, and we'll discuss what each of these is individually and what it looks like. All right, but this is a pretty nice little sketch here. Something like this in your notebook would be a good idea because it shows how these different load situations are affecting the building. Okay, so for your wind loads, notice how there are arrows that go all over the place. If you have ever watched some disaster movies about hurricanes or tornadoes or things like that, you'll notice that the wind doesn't just blow over buildings, but the wind will like pull the roof off of buildings and do all kinds of crazy stuff and blow out windows and things like that. And that's because it's not just a uniform just pushing against the side. There will be some suction on the other side, and there can be uplift on the roof. And so there's a lot of interesting loading situations that have to be taken into account when you're looking at the wind load. The wind load will be specified in building codes, and the wind load is unique based on your geographic location. Earthquake loads, if you look at where the epicenter of this, or hypocenter I guess, of this earthquake is, you can see that it radiates out, and so how it hits the building is not necessarily a straight up and down or a straight side to side. And so that's why 2 slides back, when you had the seismic or earthquake loading, it was these weird wiggly lines, because earthquakes can put forces or loads onto the building in all kinds of weird directions and locations. So that's what the seismic loading looks like, and that will also be based on where you're located. Some parts of the country are going to have a lot more significant seismic loading than others. Flood loads. Flood loads are something that hopefully we're not going to have to accommodate, but your important thing is that your water surface build above the base flood elevation, which is the water surface elevation resulting from a flood with a 1% chance of equaling or exceeding that level in any given year. All right, so lateral force resulting from static and dynamic water pressure. Yeah, you're not supposed to build in flood zones. Soil pressure loads. Soil pressure loads are a little bit like if you swim in a deep pool and you go into the deep end, you go way down, and you notice that the pressure is a lot higher the deeper you go. Well, the same thing happens with soil. And so if you have a foundation, the soil pressure is going to be greater the deeper you go down, because there's all the soil on top of it. All right, and so that's something that obviously that basement wall there, that foundation wall, needs to hold everything above it, but it also needs to withstand the pressure of all of this soil pressure pushing against the foundation wall. I think I'll stop there and pick this up in a moment.